Lesson 18 is all about combining like terms. Now, there's two ways in which we're going to learn about combining like terms. One of algebraic expressions that don't have exponents, and then another set of examples that do have exponents. Let's break that down. You look at practice problem A, B, and C here, you notice that none of these algebraic expressions have exponents in them. Therefore, when we're looking at combining like terms, we're looking to see if they have the exact same variables in order to put those pieces together. If you look at letter A for an example here, I got negative 2xy. That can be put together with negative 4xy because they've got the same set of variables. Negative 2xy and negative 3x don't go together because there's not the same variable that is in this term. Now I went ahead and I did a little strategy that maybe isn't right away in your textbook. I've circled and or put different shapes around the terms that I know are alike with each other. Therefore, I'll be able to identify how those things go together. My kids have this little toy at home where they've got these different shapes, and these shapes fit through the same size hole, and they fall into this little drum, this little bucket. The only way that they fit in there is if they are the same shape going into the same hole. The little triangle goes in the triangle, the circle goes in the circle, and they learn their shapes that way. Well, I use that same principle when I'm solving and combining like terms. If they have the same terms, I put the same shape around them. That way I know how to put those items together. Let's take a look at A, B, and C, combining terms without exponents, and then we'll come back to learning how we want to do that with exponents a little bit later in our lesson today. In letter A, I've got negative 2xy minus 3x plus 4 minus 4xy and minus 2x. Now, I can use some of the properties that I already know in terms of simplifying algebraic expressions to put these together appropriately. Sometimes you might have to use the distributive property if there's an exponent that you're multiplying or a variable that you're multiplying. Sometimes you might need to use the commutative property or the associative property to rearrange things to simplify them. Here I'm going to use that commutative property and move things around to rewrite the expression so it's easier to put those like terms together. Here I've got negative 2xy. I've got negative 4xy. Now if I keep the mathematical expression with that term, it doesn't change anything in the expression because technically I'm just saying I'm minusing this. It's just in a different order in this case with those like terms. Next I would write negative 3x, negative 2x, and then positive 4. Notice I kept either the subtraction or the addition with each of the terms in it and then put those into an order to where I can now combine these terms, and leave that guy all by himself because there's nothing else to be combined here. I've got negative 2xy minus 4xy, same sign sum. So negative and negative, you're going to do the same sign. Add those together. 2 plus 4 is 6. Keep the sign negative. Negative 6xy. Here I've got negative 3x minus 2x, same sign sum. Add them up. 3 plus 2 is 5. Because it was negative, it remains negative. And then positive 4 stays right there. So I have identified the like terms, I've rearranged them using my commutative property, and then I'm able to simplify with those mathematical expressions how to add and subtract real numbers. B, 7m minus, in parentheses, negative 8m plus 9m. Now, anytime you see this minus sign right here in front, that actually means that you're going to apply your distributive property as if that this was a negative 1. A negative 1 can be multiplied by each of the parts that are inside of this, so I would have 7m minus whatever's going to be multiplied here. Negative 1 times negative 8m. Two negatives makes a positive 8m, so it's plus 8m, and then plus 9m. Now all of these have the same term. They've got the same variable behind them, so I can simply add up the coefficients that are in front of them. 8 plus 9, 17, plus 7 is going to give me 24. 17 plus 7 is 24m. Letter C. I've got 3yac minus 2ac plus 6acy. Now, here's where sometimes students get confused because they see that the order that yac is different than the order of acy, even though they're the same letters, right? I've got a y in each, I've got an a in each, and I've got a c in each. Order doesn't matter in this case, as those are all factors that are going to be multiplied. These are all factors that are going to be multiplied, so they're like terms, even though the order is different. If you can identify that they're all the same variables, then they're still like terms. So I can rearrange this with my commutative property and put these together. I'm going to say 3yac plus 6, and if I want to rearrange this, I can as well. yac minus 2ac. My like terms again, I can identify with my shapes. Then I add those two coefficients together. 3 plus 6 is 9. yac minus 2ac. There's nothing to change here because there are no other like terms that you would be combining. Second portion of combining like terms has the factor of exponents being added into our algebraic expressions. Now here, when you're adding algebraic expressions, you have to make sure that you're recognizing that there's addition or subtraction going on instead of multiplication. When you have our product property of exponents, which multiplication happens with exponents, you can add the exponents, but in this case there's addition happening, so it's simply adding the coefficients in front of the sequence of exponents and the variables that we have. So let's take a look at how we do that and how it's a little bit different than when you have like terms with just regular variables, because now you have to factor in to have the same base and exponent as your like term. Letter D, you've got x to the fourth y plus 3x to the fourth y plus 2x to the fourth y. Now, anytime that I see that there's no coefficient here, I can always assume that there's actually a 1, and that helps me to add those items together. So I have 1x to the fourth y plus 3x to the fourth y plus 2x to the fourth y. They're all x to the fourth y. I have a missing leading coefficient here. If I think about this as simply a 1 plus 3 plus 2 problem, it becomes a lot easier to do because I have the same set of variables and exponents in each. 1 plus 3 is 4, plus 2 is 6, x to the fourth y. Letter E, x squared y minus 3yx plus 2yx squared minus 2xy plus yx. I need to make sure that I have rewritten this appropriately or put together the right pieces in order to add these terms correctly, because some of them are in different orders, so I should identify what terms I have that are alike. If I put a variable here a coefficient here that's 1, I've got x squared y. Where else do I have any x squared y's? Yx squared is the same as x squared y, so these two items will be added together. Negative 3yx, negative 2yx, and positive yx with a 1 in front of it will also be put together. So I'm going to circle those to say that those items will be combined. Now I can rewrite this using my commutative property and then put those terms together. Here I've got x squared y plus 2yx squared. So this is 1 plus 2. That's going to give me a total of 3yx squared for that portion. In the second portion, I have negative 3yx minus 2xy plus yx. All of those are the exact same because it's an x and a y, an x and a y, an x and a y, and the exponents are the same in each of those terms. So I have negative 3 minus 2 plus 1. Negative 3 minus 2, same sign sum. I would add those together. That would be negative 5xy plus 1yx. Different, subtract. 5 minus 1 is 4. Keep the sign of the large number, which is going to be negative. So my final answer, negative 3yx squared minus 4yx. And for letter F, I have to do the same thing, but identify that I have different sets of variables with different sets of exponents in this expression. M to the third, n to the first, n to the third, n to the first. Those are like terms because they're exactly the same in terms of the variables that are in the base and the exponent that's above them. So I'm going to put a little block right around there and say those are like terms that can be put together. Negative x squared y to the 7th plus x squared y to the 7th. These are also like terms that can be put together in their separate fashion. So I've got two sets of different variables because they have the same variable and exponent in each of those. Let's put each of those two sets together. This would be, with the coefficient in front of it, 1 plus 1 is 2, m to the third n, and this is negative 1 plus positive 1. Negative 1 and positive 1 are going to cancel each other out, so this portion is actually eliminated, and my final answer is right there. Biggest difference between combining like terms without exponents and combining them with exponents is to make sure that you have the variable and the exponent. And if you see it where it's ever written in a different order, you can always rewrite it to actually make it in that same order so it doesn't get confusing. Well, those things aren't the same because it's x squared y or yx squared. They actually are the same because there's the same number of those variables in each one. Be very careful also when you're combining like terms with exponents that you don't jump to multiplying those exponents and then adding those exponents together. I see students all the time that will say x to the 4th plus 3x to the 4th, and they'll say, well, 4 plus 4 is x to the 8th. That's not what's happening here. Because it's addition, we're just adding the coefficients that are in front of those larger variable terms. Okay? The final portion of our practice problems in lesson 18 asks us to apply this process of combining like terms with a word problem. Here it's asking us to find the perimeter of this triangle. To find perimeter, you're adding the length of the sides all the way around an object. In this case, you would add up this side plus this side plus this side. I took the liberty on rewriting that all the way out as one expression. So you see x plus 1 plus x squared plus 1 plus x squared. So I have all three sides added into one expression. Can I simplify this by combining like terms? The answer is yes. I have to think about the exponents that I have and the variables that I have and put together the like terms by using the commutative property to rearrange those. I'm first going to circle and or use my shape method to identify what can be put together and then rewrite it to do that exactly how I want to. I've got an x squared and I've got an x squared. I've got plus 1, I've got plus 1, and then I'm going to use a different triangle shape here, the third shape that we've added in, because that's a different term altogether. X cannot be added to x squared because x squared actually is multiplication that's happening. It's not just a single variable. Let's rewrite that. I would then have x squared plus x squared, that's these two. I would have plus x for this one, and then plus 1 and plus 1. Let's put those together. These two added together, I'm adding the coefficient, not the exponent itself. So x squared plus x squared is actually 2 x squareds plus x, and 1 plus 1 is 2. Here's my final answer. So the combination of adding like terms by identifying the different parts that are like and then combining those, because I have variables and with exponents and without in this case, in the form of this word problem. Anytime it asks you to find perimeter, it's just simply adding all the length of the sides around that shape. If there are variables that represent those shapes, you can write it out in one large expression and then break it down by putting those like terms together. God's blessings on your homework.